Hello, in this video we will discuss about average and instantaneous acceleration. So what is acceleration? Acceleration is basically how much velocity changes in 1 second. Okay, so how to find acceleration, which is average acceleration, is basically the change of velocity divided by time elapsed or time taken for that change. Suppose there is a particle or an object which moves through some distance. During this movement, velocity changes from v1 to v2. Okay, so initial time is t1, final time is t2. So we can say that the time taken, so the time taken is delta t equals t2 minus t1. So this is the time taken. So how to find average acceleration? We can find change in velocity, which is v2 minus v1 delta v divided by t1 minus t2, which is delta t. So the average acceleration is delta v by delta t, which is equal to v2 minus v1 by t2 minus t1. The unit is meter per second square. Now consider this example. One car is moving to left side. Now time is t is equal to 0. Velocity is minus 10 meter per second. You see the vector which is directed to left direction, which is the velocity vector. Now suppose there is an acceleration in the same direction of the velocity. This is very important. Both acceleration and velocities are in the same direction. Both are negative quantities because we take negative direction as left direction as negative. Now what is going to happen is the rate at which the velocity is going to change is minus 2 meter per second per second. So every second the velocity is going to change, the magnitude is going to change 2 meter per second, and that is in the same direction of the velocity. So what happened to the next second? So initially it is minus 10 meter per second. After 1 second, this will increase, right? The 10 will change to 10 plus 2, but there is a minus sign, right? So since there is a minus sign, so we say that it reaches minus 12 meter per second. Again, we will say since minus 12 is smaller than minus 10, we say the velocity decreases. Okay, velocity decreases. However, the magnitude is increasing. Look at here. After 2 seconds, what happens? So every second it is going to change by 2 meter per second, right? So after 2 seconds, it will be minus 14.0 meter per second. 2 plus 2. Every second minus 2, it increases, right? So, sorry, minus 2, it decreases since it is minus. So velocity decreases, but it is important to note that the magnitude or speed is actually increasing. Now let's consider this situation where velocity is minus 10 meter per second. The same situation. If he is applying brake, that means the acceleration is in the opposite direction. So they are in opposite signs, like the minus and plus here. So every second, what is going to happen? The magnitude is going to decrease. Okay, so after 2 seconds, the velocity of this car is minus 6 meter per second. So minus 6 is bigger than minus 10. So we say velocity increases, but magnitude or speed decreases. So third example, time 0, initial velocity is 10 meter per second. Okay, starting velocity is 10 meter per second. Acceleration is opposite, say minus 2 meter per second square. So what is going to happen? The magnet, since they are on the opposite direction, the blue and green, they are opposite direction, magnitude is going to decrease. So after 2 seconds, velocity will be 6 meter per second. Okay, 6 meter per second. Velocity decreases, you see, velocity decreases from 10 to 6. Magnitude or speed also decreases. So this is very important to note. Okay. Now we talk about instantaneous acceleration. What is instantaneous acceleration? We were talking about average acceleration before. So average acceleration over an infinitesimally short interval of time. Okay. So very short duration of time, if you calculate average acceleration, it is basically instant. Or in other words, the acceleration at an instant of time, or at a point of time. Okay. So we know how to find acceleration, average acceleration. This is the formula. Now in the limiting case, when delta t, this time difference, when it approaches 0, we can write the instantaneous acceleration as dv by dt. Basically, the velocity function you need to differentiate. Okay. So we already know that what is velocity, right? Velocity is dx by dt, you see. So acceleration is dv by dt. Again, so what is v? V is dx by dt. So d by dt of dx by dt. Okay. Now it is equal to d square x by dt square. So this is, if you want to find acceleration, you can use the position function, okay, function, and then differentiate it 2 times, you can get acceleration. Velocity function, if you differentiate once, you will get acceleration. Position function, you need to differentiate 2 times. The instantaneous acceleration is the derivative of the velocity with respect to time. Now if you plot a graph, velocity versus time, suppose there is a constant acceleration, you get a straight line. And for example, if you have to find acceleration, take 2 points, for example here, 3 second and 12 second. The corresponding velocities are 6 and 12. So the difference 12 minus 6 and 12 minus 3 gives you delta v and delta t. So acceleration is equal to the slope of the velocity versus time graph. So just find the slope. What you will get is acceleration 0.67 meter per second square. Average and instantaneous acceleration. Now summary is that acceleration is a vector quantity. You can find average acceleration like this. Acceleration is a change in speed or direction or both. Instantaneous acceleration is basically you need to take the first derivative of the velocity function, which gives acceleration at a specific instant in time. So if you want to demonstrate what is instantaneous acceleration, let's consider this velocity time graph. This black line is actually the velocity function with respect to time. Now if you are asked to find the average acceleration between t1 and t6, you just take this point here and the second point here and draw a straight line between them. Okay, so if you find the slope of this line, okay, then you get the acceleration. But in case if you are asked to find the acceleration at this t0 time, okay, at this instant of time or at this instant of time, basically you need to get the slope of this tangent. Okay, so you need to plot a tangent at this point. So slope of this tangent is the instantaneous acceleration. So this is again here you can see you want to find the acceleration at this instant, you find the tangent, and the slope of this tangent will be the acceleration at this instant of time. Now let's do a problem. A particle is in motion and is accelerating. The functional form of the velocity is, the velocity function is this. Okay, so velocity depends on time. Now find the instantaneous acceleration at 5 seconds. So you need to find what is the acceleration at 5 seconds. So the first step is, let's simplify it. Vt is equal to 20t minus 5t square. The acceleration is dv by dt. Okay, dv by dt. So acceleration is d, substitute this function here. So you get 20t minus 5t square by dt. Then taking the differentiation of these two separately. First take this 20 out because it's a constant, 5 out. So you get 20 dt by dt and 5 dt square by dt. So what is the differentiation of dt by dt? It is 1. So 20 into 1 minus 5. The differentiation of t square will give you 2 into t raised to 1 because 2 minus 1 is 1. So 5 into 2 into t minus 1. So in the end you get 20 minus 10t. So you see acceleration also depends on t. So that's why acceleration is a function of time. So if you want to find out what is the acceleration at time equals to 5 seconds, just substitute 5 here and you get minus 30 meter per second square. Okay, so now if you look at the graph, so you know the acceleration is function of time. So if you look at this velocity function, okay, so velocity function, if you find the velocity at t is equal to 5 seconds, so just substitute 5 seconds here, 5 seconds here, you will get minus 25 meter per second. So when this is the velocity time graph, when time is 5 seconds, you see the velocity is minus 25. So if you analyze this graph, this green line is basically the plot of this function Vt. So if you put t is equal to 0, you get this point. T is equal to 1, this one. T is equal to 2 here. T is equal to 3, like that. At t is equal to 4, you can see velocity becomes 0. Okay, velocity becomes 0. So what is really happening? You see, initially velocity was positive and then suddenly the velocity changes its direction and becomes negative. Okay, it's a velocity changes its direction and reaches 0 and then it starts to become negative. Okay, so what happens here is initially the velocity changes in the positive direction. So actually what is happening is velocity increases here, but after some time the velocity decreases. Okay, after some time velocity decreases and then it changes sign. Velocity decreases and it becomes 0 at point, means it stops, and then it changes sign. Okay, so if you look acceleration, you can see that at t is equal to 0, here acceleration is positive. You get 20 meter per second square. At time t is equal to 1, you get 10 meter per second square. So here also what is happening is acceleration is positive, but the acceleration itself is reducing. Okay, so the rate at which the velocity was changing is reducing. If you put t is equal to 2 seconds here, if you put t is equal to 2 seconds, basically what you will get is a equals 0 meter per second square, right? So what does it mean? There is no acceleration here. Afterwards, t is equal to 3. If you put t is equal to 3 here, you get minus 10 meter per second square. So acceleration is negative from this after this, okay? So you can see that after this point acceleration becomes negative after 2 seconds. That is why the velocity is decreasing. So up to here acceleration and velocity both are in the same direction, but here they are in the opposite direction. So at some point what happens, the velocity becomes 0. That means the object stops moving, and then it reverses the direction and it moves to the negative direction. Okay, so this is how we analyze velocity time graph. So if you this is the most important part of this discussion, motion with constant acceleration. Suppose we imagine that there is a car here which moves to this position near a signal. Okay, the initial time, we start a stopwatch, the initial time say t0 is 0, the position, our origin is here, origin is here, so the initial position is x0, initial velocity is v0. Okay, initial velocity can be 0 or any other value. Initial position need not be origin all the time. Okay, initial time also can be different. So in this particular case we take initial time is 0. Now it is under constant acceleration and it reaches at this point. We call the time now is t. Okay, so we say final time is t. So what is the time duration? Basically delta t is t minus 0, right? Initial time. So basically delta t is t here. So what we have here, t is the time taken by the car to reach here. Suppose if we have t1 and t2, we should take t2 minus t1, the duration. So this t represents the duration. X is the final position. So what is the distance or displacement? X minus x0. What is the final velocity? V. Now we have some equations. Okay, if some of these parameters are given, we can calculate the final parameters. For example, if we know the initial time, initial velocity, and if we know the acceleration, what is the final velocity? We can use this equation. We can find the final velocity if we know v0, a and t. T here is the time taken. In actual case it is t2 minus t1, the duration. Similarly, if you know the initial position, final position, x and x0, okay, and initial velocity, time taken and acceleration, we can use this equation to find any of these parameters if other parameters are given. Suppose you take this x0 to the left side, you get x minus x0. It is delta x, the displacement. In school you might have used the letter S, displacement. Okay, so another equation is v square, the final velocity square, equal to initial velocity square plus 2 acceleration multiplied by x minus x0, which is delta x. The speciality of this equation is there is no time. So in the problem, if you don't have time duration, you can use this equation to find one of the parameters and use it with other equations to find the final parameter to be calculated in the question. Okay. Uh, Now we will use those equations to solve some problems, and I will show you in the next lecture. So another case is free fall. Okay, free fall is a special case when things are falling under the influence of gravity. For example, this person, this apple and plane, all of them are falling under the influence of gravity, right? So the acceleration of all these objects, irrespective of their masses, you know, the airplane has more mass than Apple, but all of them will be accelerated at the same constant acceleration, and you know it is 9.8 meter per second square. We write it as g. So g is the acceleration due to gravity, okay, towards the center of the gravity. Everything is accelerated. The value is 9.8 meter per second square. So again, in summary, if for example you drop any object, it falls under the influence of gravity. You can see the velocity is changing 20 to 80 meter per second square here. You see it when it traveled a distance h. So because the velocity changed, because there is acceleration, that acceleration is due to gravity, and the value is 9.8 meter per second square. So if you take up direction as positive y, then acceleration due to gravity is in the opposite direction. It is always towards the ground, right? So this value will be negative. Suppose you decide that the down direction is positive, then the acceleration due to gravity and y direction are same, positive direction. So the value is positive or negative depending on the positive direction of y-axis you choose. Okay, so both are correct. You can stick to one of them. Now let's do one problem here. Suppose a car merges into freeway traffic on a 200-meter long ramp. Okay, so a car is entering from freeway to a road to a freeway, okay, highway, on a 200-meter long ramp. If its initial velocity is 10 meter per second, you see v0 is given, and acceleration is 2 meter per second square. Acceleration is given. How long does it take the car to travel 200 meters? How long means time. The duration of the time to cover 200 meter is that we want to find out. We need to find out. So first thing to do is draw a picture. So this is the ramp. Initial position is 0. Final position of the car is x, 200 meters. So the car is traveling from here to here. It covers a distance delta x, 200 meter. That means x minus x0 is 200 meters. Initial time t0 equal to 0. The final time is t. So the duration of this travel is t minus t0, which is t. So what is this t we need to find out? Actually, that is the time duration, right? From the left to right, covering 200 meter. Initial velocity is given, acceleration is given. We can find even velocity as well. So we have to use this equation basically. All right. So if you use this equation to find time, see time is here, acceleration is there, initial velocity is given, but you don't have final velocity, right? So you cannot use this equation. But you can use this one because final position is given, initial position is given, initial velocity is given, acceleration is given. So you can find this time. So basically what you need to calculate is time. Okay, so you substitute the values 200, x0 is 0, initial velocity is 10 meter per second, time we don't know, half, acceleration is 2 meter per second square, and t square. Then if you take all these things to all these values to right side, you get minus 200 plus 10t plus 1t square. Okay, this can be arranged again in this form. Why? Because this is in a quadratic equation. This is a quadratic equation in time t, right? For example, ax square plus bx plus c equal to 0. You know how to find the root of a quadratic equation, the value of x, by using the root equation. I'll show you. Here in this equation, a is 1, b is 10, and c is minus 10, minus 200. Okay, it's very important. So you can use this equation. So what you would get by solving this, you get two roots actually, minus 20 and plus 10. So since we are calculating time, it should be positive. Okay, so positive root is 10 seconds. So the answer is 10 seconds. Why? Because positive root is only the physically meaningful value here for time. So this is how we solve problems. So now we can even find velocity. If you know time 10 seconds, you can substitute here. We know v0, we know a, we can calculate v. Okay, I leave it to you.